guys, this is the code that we wrote in the last video, and in this video we are gonna implement this code to classify a data. And for that I have imported make blobs. I have imported make blobs from sklearn.dataset, and from that I have taken 500 samples, and I have only two features, and it also has two centers. So basically it is going to be a binary classification, and of course we know that logistic regression is only capable of binary classification, and the random state one is going to confirm that every time we are going to run our program it is going to be same, otherwise our data will be changing if we do not set a random state here. So let me just run this. Okay, now if you have wait a second. Yeah, now if you have seen my previous videos, then you will know that to apply this formula we have to add a dummy variable to the x. So that's what I'm going to do here. So first of all I'm going to use ones, and I'm going to do np.1, and in this I'm going to give the shape of what we need is, let's suppose this, and we have a shape of m. So we need m times 1. Okay, so we need this shape, and so it is going to be m, not m, x dot shape 0 and 1. This is going to be the shape. Now what I'm going to do, x equal to np dot hstack, and in this I'm going to pass ones, and I'm going to pass x. So now if you will see x, we have this value here, right here. Okay, now we have this. So what I'm going to do before adding, let's just do this. Okay, so np dot scatter, and here I'm going to pass our x, I'm going to pass our y, and let's just see whether what is going to be our data. And np, oh sorry, it is my fault, it should be plt dot scatter. Okay, so it is saying it is wrong, and x and y must be the same size. So let me just check the shape of them. X dot shape is going to be 500 times 3, and y dot shape, it is 500. So these are the same shape. Okay, so what we have to do here is we need to convert this into 500 times 1, the shape of this, and both of them are similar, but this is basically 1D and this is basically 2D. So that is the main difference here, although the data will be same. So let me just also do that, and what I need to do is y dot reshape, and here I need to provide 501. Okay, so we have done this, and I think I also need to store it in 5. Okay, so now if I will do plt dot scatter, it is going to store x, y. Okay, so x and y must be the same size. Let me just check what is wrong with it. Oh, okay guys, so it was my mistake. Basically in this case what we have to do, basically we have 3 dimensions. Okay, and when in x we have 3 dimensions, and when we are plotting a graph like this, it only has 2 dimensions. On the 1 dimension it is going to be y. So on the x-axis I can only represent one of these 3 dimensions. So that's what I'm going to do here. What it is going to do is x, I need all the rows, but I need only the first column. Let's see, it should be working now. Yeah, so as you can see that it is a classification problem, so either the output is 1 or the output is 0. Also guys, just delete this line, and we are not gonna do this anymore. Okay, so now we have done this. Now let's just implement or let's just apply our algorithm on this data. Okay, So let's run this, and I'm going to call or let's take theta error list. And in this what I'm going to do right now, I'm going to call gradient descent, and I need to pass our x and phi. So now it has run successfully. So let's plot the values of error. We will see whether our error has decreased or not. So let's take plt.plot, and I'm going to pass error list. And as you can see here, our error has decreased so much. So it is even less than 0.1, so it is very good. And let's see our output, what is the values of our output. So let's take y prediction is going to be hypothesis, and in this hypothesis I'm going to pass the x, the original x, and I'm also going to pass the theta. So what are we doing? Basically, we had some values in our training set, and right now I am also predicting on the basis of these points. So I'm again predicting on the basis of these points. So it will tell us whether our accuracy is good or not on the basis of the training set. Okay, it is going to tell us that. And although it is not a good idea to test on the training set, but here in this case we can do that. It is not a big deal. So let's see what are our outputs, and we have y hat here, and these are our outputs. So as we said earlier in my previous videos, like our output is going to be range between 0 and 1. So what are we going to do now is that if the output is more than 0.5, then it is going to be 1, and if the output is less than or equal to 0.5, then it is going to be 0. So I am going to do this. So let's do y, and in this y greater than 0.5 is going to be 1, and we are going to do again y less than or equal to 0.5 is going to be 0. Now if we will see our output, and I did one thing wrong. It should not be y, it should be y hat, y hat, y hat, and y hat. So y hat is going to be, now all the values are in 0 and 1. Now to check the accuracy, whether our output has each same values or not, there are two things that we can do. First of all, let's just delete this line. Okay, and now let's get this plt.scatter this, and now what I'm going to do, plt.scatter, instead of the original y values or original outputs, what I'm going to do, I'm going to use our predicted values, and in this I'm going to give the color red. So if everything goes well, then our red dots should be over these blue dots. Okay, so let's test this plt.show. So as you can see here, you cannot see a single red blue ball, and the reason is that because our output or our algorithm has predicted very good. So let's just comment this line and we'll see the output. So as you can see here, this original line has the output of blue, and when we will do this, then it is going to be red. Okay guys, so the next thing that I need to tell you is that we need to find the accuracy. So the second way is to find the accuracy is pretty easy. What I'm going to do, I'm going to use np.mean, and in this I'm going to pass y hat equal to y, and as you can see here, 1.0 means that our algorithm is giving 100% accuracy. although this would be considered as overfitting, but we are dealing with a very basic data set. And the second thing is that we are also doing this prediction on the basis of the training set. So if we will have a test data set, then it is not going to predict 100%, but it could. We will see when we will make a project on this, then we will see that it is not going to generate every time 100% what do we say 100% results. So even if you run even if you will run this data set on the sklearn library, then it is also going to give 100% results. So our library has done wonderful. But in the next video, what I'm going to do, I'm going to show you a way to represent these equations good, because right now you cannot what do we say right now you cannot represent them well, and people will not be able to understand this data very easily. So in the next video I'm going to implement that part. Thanks for watching, and I'll see you next time.